Hi friends, today I am giving a lecture on differences between DFA and NFA in theory of computation or FLAG, finite languages and automata theory. Okay, so the differences between DFA and NFA is one of the most important questions in theory of computation or FLAG. Okay, so there are two types of finite automatas are there. First one is DFA and the second one is NFA. So DFA stands for Deterministic Finite Automata. NFA stands for Non-Deterministic Finite Automata. Okay, so the first difference is DFA stands for Deterministic Finite Automata. NFA stands for Non-Deterministic Finite Automata. Next, second difference, how DFA can be defined. DFA can be formally defined by 5-tuple mission. So that mission is represented by capital M. So the 5 tuples are capital Q, sigma, delta, Q naught, F. So what is capital Q? Q is the set of non-empty set of states. Okay, non-empty set of states. Finite non-empty set of states. What is sigma? Finite non-empty set of input symbols. Okay. Delta is the transition function which maps Q into sigma tends to Q. Q naught is the initial state. Q naught belongs to capital Q. And the capital F is the set of final states. So F subset equal to Q. Okay. F also belongs to Q. Q naught also belongs to capital Q. Okay, so these 5 tuples can be defined by using some example. So this example denotes the DFA model. Okay, so this DFA model, in this one only some states are there. States are nothing but what are the symbols that are Q0, Q1, Q2? What are the symbols that are put in circles that can be called as states? Okay, here Q0 is put in circle, Q1 is put in circle, Q2 is put in circle. So these are called as states. Okay, Q0 is one state, Q1 is another state, Q2 is another states. Next, what are the input symbols are there? Input symbols are represented on the edges. Edges is nothing but arcs. These arcs represents the edges. So this is one arc, this is another 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 arc. Arc or edges. What are the symbols that are put on the edges that are called as input symbols? What are the symbols on the edges of there? That is only 0 and 1. So here 0 and 1 are called as input symbols. Okay. Next one. Delta is the transition function which maps Q into sigma tends to Q. Here Q is nothing but set of states and sigma is nothing but set of input symbols. A state, a particular state with particular input, it can goes to particular output state. So that is the transition function. So while considering this example, okay, capital Q is nothing but set of states. What are the states are there? Q0 state, Q1 state, Q2 state. Okay, sigma is the set of input symbols. What are the input symbols are there? Symbols that are present on the edges. Only 0 and 1 are called the input symbols. Now we are going to the transition function Q into sigma. So for example, now considering this transition function delta, transition function can be defined by, represented by delta of Q naught comma 0. Here Q naught is the one state that belongs to capital Q, and 0 is the input symbol that belongs to sigma. Okay, Q naught state with 0 input, it can goes to some output state. What is the output state? That is Q naught. So now this can be represented in the diagram. Q naught state with 0 input, it can goes to again Q naught state. So delta of Q naught with 0, Q naught state with 0 transition, so it can goes to some output state, that is Q naught. Again, so Q naught state with the input 1, it goes to Q1 state. Q naught state with the input 1, it can goes to Q1 state. Next, Q1 state with 0 input, it can goes to Q2 state. Q1 state with 0 input, it can goes to Q2 state. Okay, Q2 state with the input 1, it can goes to Q1 state. Q1 state with the input 1, Q1 state with the input 1, it can goes to Q1 state with the input 1, it can goes to again Q1 state. So these are the transition functions. So these transition functions are defined by delta symbol. Okay, 1, 2, 3, 4, 5, 6. 6 are the transition functions. And Q naught is the initial state. At which state, so arrow symbol is there, that state can be represented as starting state or a initial state. For which state arrow symbol is there? So for Q naught state, arrow symbol is there. So then it represents the initial state or a starting state. Next, it belongs to capital Q. Okay. Next, F is the final state. Final state can be represented by double circles. Which state has the double circles? So that state represents the final state. So now observing this DFA model, so Q naught state has the 2 circles. So this Q naught state is the final state. So this final state belongs to subset equal to capital Q. Okay. So now after observing these 5 tuples, now mission M can be defined by Q is equal to finite set of states, that is Q naught, Q1, Q2, Q naught, Q1, Q2. Sigma is the set of input symbols. Here input symbols are 0 and 1. So 0 and 1 are input symbols. Delta is the transition function which maps Q into sigma tends to Q. So delta of Q naught with 0, that is Q naught. Delta of Q1 with 0, it can goes to Q1. Delta of Q2 with 0, it goes to Q naught. Delta of Q naught with 1, it goes to Q1. Delta of Q2 with 1, it can goes to Q1. Delta of Q1 with 0, it can goes to Q2. Next, Q naught is the initial state. Which state has the arrow symbol? So that state can be called as initial state. So here Q naught is the initial state. Next, F is the final state. Which state has the double circles? So that state represents the final state. So here Q naught state has the final state. Okay. So this is the DFA can be defined by 5 tuple formulation, and this is the example. Okay. Next, goes to the NFA. A NFA is defined by 5 tuple formulation. Same, M is equal to Q comma sigma comma delta comma Q naught comma F. Okay, all are same. So except delta. Delta is the transition function. Here, transition function delta can be defined in the case of NFA is q into sigma tends to 2 power q. Here 2 power q is the power set of q. Power set of q. Q into sigma tends to 2 power q, where q is the power set of q. Okay. So here q is the finite non-empty set of states. Sigma is the finite non-empty set of input symbols. Delta is the transition function which are defined by q into sigma tends to 2 power q, and q naught is the initial state and f is the final state. Only difference between DFA and NFA in the case of only delta. Delta is the transition function. In the case of DFA, delta is defined by q into sigma tends to q. In the case of NFA, q into sigma tends to 2 power q. So 2 power q is nothing but power set of q. So how many number of states are there? So while considering this example, how many number of states are there? So 3 states are there: q0, q1, q2. Power set of q is nothing but 2 power q, that is 2 power 3, that is 8. So q into sigma tends to 2 power q, that is 2 power 3, that is equal to 8. Okay. So now for this example, the mission can be defined by, so q is the set of states, that is q0, q1, q2. Next, sigma is the input symbols, only 0 and 1, and delta is the transition function. So this transition function, delta of q0 with 0. q0 with 0, it can goes to either q0 or q1. So q0 with 0 goes to q0, q0 with 0 it goes to q1. So therefore delta of q0 with 0, it can goes to q0 comma q1. Next, delta of q1 comma 1. So del q1 with 1, it can goes to q2. Delta of q1 with 0, that is equal to epsilon. There is no state is there. Okay, delta of q2 with 0, there is no input, so it can be represented as epsilon. Delta of q2 with 1, there is no state is there, so it can be represented as epsilon. Okay, delta of q1 with 0, that is also epsilon. Okay, next one, starting state. So which state has the arrow symbol initial? So that state represents the input state. Which state has the double circles? That can be represented as final state. Here q2 state has the double circles, then it can be represented as final state. Next, the fourth difference, the transition takes place from a state to a single particular state for each input symbol. Okay, so here by observing this example, so q0 state with 0 input, it can goes to unique output state, that is q1. q0 state with input 1, it can goes to unique output state q2 state. q0 state with input 2, it can goes to unique output state, that is q3. So the transition takes place from a state to a single particular state for each input symbol. Here by considering the input symbol 0, so q0 state with 0, it can goes to unique output state only, that is q1. Okay, here q0 state with 0, it cannot goes to q2 state, it cannot goes to q3 state. A state with a unique input, it can goes to unique output state, that can be there in only DFA. Okay, a state with a unique input, it can goes to unique output state. That is possible only in DFA. Q0 with 0, this is unique input, it can goes to only unique output state, that is Q1. Q0 state with the unique input 1, it can goes to only the output state Q2. Q0 state with the input 2, only it can goes to unique output state, that is Q3. Here the inputs are unique inputs, it can goes to unique output states. Okay, so for example, one student is there, one student, he is started at the home at 8:30 a.m. Okay, it can directly goes to school only. So that is unique input with unique output state. So a student by walk, it can go, he can goes to only school only. That is DFA. Okay, whereas in the NFA, a student, he is started at the home by walk. Okay, he can goes to multiple output states. He can goes to school, he can goes to some park, he can goes to some theater, he can goes to some internet cave. Okay, so there are 4 output possibilities are there, but in the case of DFA, only with the unique input symbol he can goes to unique output state. But in the case of NFA, so a state with input, he can goes to either this state or this state or this state. So that is there in the NFA. Q0 state with 0 input, it can goes to either Q0 state or Q1 state or Q2 state or Q3 state. We cannot determine Q0 state with 0 input, it can goes to either Q0 state or Q1 state or Q2 state or Q3 state. We cannot determine. But in the case of DFA, we can determine Q0 state with 0 input, it can goes to only Q1 state. Q0 state with 1 input, it can goes to only Q2 state. Q0 state with the 2 input, it can goes to only Q3 state. But in the case of NFA, Q0 state with 0 input, it may goes to either Q0 state or Q1 state or Q2 state or Q3 state. We cannot determine. A student starts at his home by walk, he can goes to either school or a park or internet cave or some exhibition. We cannot determine. But here a student can start at his home by walk, he can goes to compulsory school. Okay, so that is the main difference between DFA and NFA. In the case of DFA, a state with the unique input, it can goes to unique output state. But in the case of NFA, a state with the input, it can goes to some multiple number of output states. Okay, we cannot determine. Okay, so this is the one of the most important difference between DFA and NFA. Okay, next one. 5th point, there are no empty string transitions in DFA. Okay, there are no empty transitions. For example, in the case of this example DFA mission, Q0 with 0, it goes to Q1 state. Q0 with 1, it can goes to Q2 state. Q0 with 2, it can goes to Q3 state. So here there are 3 input symbols are there. 3 input symbols are compulsory used in the case of DFA. Okay, so there are no empty string transitions in DFA. Here sigma is equal to 0, 1, 2. Okay, In the case of NFA, sigma is equal to 0, 1. Okay. So what is Q naught state with one input? Q naught state with one input. So there is no transition. There is no transition. Okay. Q naught state with one input. There is no transition. So that transitions are called as empty string transitions. Here epsilon is also possible. Epsilon is also possible in the case of NFA. So epsilon, Q naught with epsilon, it can goes to Q1, Q4 state. Q naught with epsilon, it can goes to Q4 state. So this transition is called as empty transition. Okay, empty transition. Q naught with the input symbol epsilon, it can goes to Q4 state. So there are no empty string transitions in the case of DFA. Whatever the input symbols are there, that input symbols are compulsory used in the case of DFA. But there is no epsilon transition or empty transitions are not allowed in the case of DFA. But in the case of NFA, so empty transitions are possible. Next, it is very difficult to construct. So it is very difficult to construct DFA for a given problem, but it is very easy to construct NFA for a given problem. Okay, all DFAs are derived from NFAs. Okay, so whatever the DFA missions are there, that DFA missions are derivable from NFAs, but all NFAs are not DFAs. Okay, whatever the NFAs are there, all the NFAs are not DFAs. Okay, here all DFAs are derived from NFAs. So DFAs are derived from non-deterministic finite automatas, but all NFAs are not DFAs, but some NFAs can be treated as DFAs, but all NFAs are not DFAs. Next, DFA requires more space. DFA requires more space. Okay, a state with unique input, it can goes to unique output state. So because of that reason, it requires more space. Here, NFA requires less space. A state with particular input, it can goes to many number of states. So because of that reason, it requires very less space. Okay. Next one, for every input and output, we can construct DFA mission. Okay. Whatever the input symbols are there, whatever the input states are there, by using the unique input symbols and unique states, we can construct the DFAs. Okay, but it is not possible to construct NFA mission for every input and output. Okay, for every input symbols and output states, so it is very difficult to construct so NFAs. But unique input symbols and states, we are easily to construct the DFA. But NFA, it is not possible to construct for every input and output. The next difference is, the next possible state is clearly set in DFA. The next possible state is clearly defined in NFA, in DFA. So in DFA, okay, we can take a particular state, that particular state with a particular unique input symbol, it can goes to unique output state. Okay, so that is only possible in DFA. A particular state with a particular unique input symbol, it can goes to unique output state. Unique output state is nothing but next state. Okay, the next possible state is clearly defined in DFA. Okay, whereas in the case of NFA, every individual pair of input symbol and state. Okay, we can take a state with particular input symbol. It can goes to many output states. Okay, Q0 state with the input symbol 0, it can goes to either Q1 state or Q2 state or Q3 state. Okay, we can take a state with the input symbol, it can goes to multiple number of states. Okay, that is possible in NFA. Okay, here a state with a unique input symbol, it can goes to unique output next state is possible in DFA. So a state with the input symbol, it can goes to multiple output states, that is possible in NFA. Next one. In the case of DFA, there are no epsilon transitions are there. That means in DFA, we cannot move from one state to another state without consuming a input symbol. Okay. Without consuming a input symbol from a particular state, we cannot move to next state, next possible state. Okay, compulsory a state with the input symbol, it can goes to the next possible state. But without consuming any input symbol, we cannot move from one state to next state in DFA. But in the case of NFA, from one state without consuming any to many number of output states. So because of only epsilon symbol, epsilon input symbol. So epsilon can be denoted by this symbol. This symbol is also called as null symbol. A particular state with the null symbol, it can goes to multiple number of states. But this null symbol is not allowed in DFA. Okay, a state without consuming any input symbol, it is not possible to go to next state. But in the case of NFA, without consuming any input symbol, we can move from one state to another state by using the null symbol. Okay, next difference. The total time required for running any input string in DFA is less than what is in NFA. Okay, what is the total time required for running any input string? We can take any input string, okay, to process that input string by using DFA is less time when compared to NFA. Okay, we can take any input string to process that input string by DFA, it requires very less time. But the total time required for running any input string in NFA is larger than that is in comparison to DFA. Okay, we can take any input string to process that input string by using NFA. It requires more time when compared to DFA because here the epsilon transitions are there. So okay, null symbol transitions are there. To process that any input string that contains null symbol, it requires more time to process that input string. So when compared to DFA, it requires more time to process the input string. But DFA requires very less time to process the input string when compared to NFA. Okay, so these are the main differences between DFA and NFA. So while considering all these differences, so what are the most important difference? So the most important difference is transition function. In the case of DFA, transition function is Q into sigma tends to Q. In the case of NFA, the transition function is Q into sigma tends to 2 power Q, that is power set of Q, the set of all possible states of Q. That is one difference, main difference. The second difference is every state with a particular unique input symbol, it can goes to unique output state. Here, a particular state with the input symbol, it can goes to multiple number of output states. Okay. Here, epsilon transition, null symbol transitions are not allowed. Here, null symbol transitions are allowed. While considering these 12 differences, these are the most important differences. So thank you for watching this video. If you like this video, please subscribe my channel. So Divvela Srinivasarao. So thank you.